Hello friends, today I am now going to discuss about the Zener diode. So, firstly, in this video I will discuss Zener diode, and in my next video I will complete the previous portion of the clipper and clamper. So, let's start discussion about Zener diode. Okay. So, firstly, you have to know what is the difference between the working principle of Zener diode and in the normal diode. So, for the case of normal diode, what we know, and for the case of Zener diode, first see the pictorial diagram of Zener diode. Sorry, little bit. So, in this case, it is normal diode and it is Zener diode. So you can see this is the Zener diode and this is the normal diode and this is the Zener diode. So what is the working principle? What is the difference between the working principle of the Zener diode and the normal diode? So it's very easy. So whenever we know a diode, normal diode is connected with battery, a positive portion of the battery is connected to the inside of the diode. A positive portion of the battery is connected to the N side and negative portion of the battery is connected to the P side of the diode, then normal diode is reverse biased. If it occurs vice versa, that means if occurs the opposite thing, that means a positive portion attached to P side and negative portion attached to N side, then that will be forward biased. It occurs for the normal diode, but we can see. So what we can tell from there? So normal diode, let me write clearly. Normal diode operates in forward biased. Normal diode operates in forward biased. Why? Because in the forward biased, the diode will act as wire. Diode will act as wire. That means in the forward bias, diode will act as short circuit, and in reverse bias diode will act as broken wire. So, but in case of Zener diode, what we will see the difference? In case of Zener diode, Zener diode act in reverse bias. Yes, that's the main difference between the Zener diode and the normal diode. Normal diode act in forward bias and Zener diode act in reverse bias. So from the graph you can also see that whenever you will draw the I versus V graph, it is I, it is V. For silicon diode, for normal silicon diode, cutoff voltage is 0.7 volt. So for normal silicon diode you will see that for I versus V graph, such a way. Here the figure is not so much good. I am writing clearly. So for normal silicon diode, the I versus V graph will be like that. This is cutoff voltage. If it is silicon diode, then it will be 0.7. And here in the positive portion of the I and V, you can see that portion of the graph. But in case of Zener diode, what you will see? In case of Zener diode, you will see I versus V graph, and this is the, let me erase this portion. I versus V graph, and if you can see that this portion, from this portion the graph is decreasing continuously. So this portion voltage is called VZ or Zener voltage or knee voltage, and this current corresponding to this Zener voltage, that is I knee current or I minimum current or Zener current. So first let us try to discuss the operation of this Zener diode. So from this graph, let me draw clearly. First erase this portion of the graph. Whenever I will draw the I versus V graph of the Zener diode, whenever I will draw the I versus V graph of the Zener diode, you can see firstly this is stable up to normal Zener voltage. After that it is decreasing. So whenever we are drawing it, so this is Zener voltage and this is Zener current. This is IZ, this is VZ. Okay, so before achieving, and this portion is known as breakdown. This is also known as breakdown voltage. This famous name, breakdown voltage. So one thing you can notice from this graph that before achieving the breakdown voltage, Zener diode in this portion, Zener diode will act as or will behave as broken wire. Broken wire means what? No current can pass through it. Whenever it once achieved the breakdown portion, so you can see that up to this portion before achieving the breakdown voltage or breakdown current, it will act as broken wire. After it achieves the breakdown voltage, it will behave as broken wire once it achieved breakdown voltage or once it crossed the breakdown voltage. That's why Zener diode is maintained by breakdown voltage. So we will try to know the reason behind this. Whenever, let me change the pen color. Whenever you are drawing PN junction, here P junction, here N junction, here holes, here electrons, suppose here negative, here positive. So whenever once breakdown is achieved, after the breakdown achieved, a large current will be achieved. After the breakdown voltage is crossed, then a large current will be achieved and a large amount of recapture here it is electron, it is holes, electron, holes, electron, holes. The large amount of recapture will take place. This is the depletion region. Inside the depletion region, then we will get sharp current, and in this region, if we increase V0, that means if we increase the biasing, then width region will increase and electric field will increase, and that's why covalent bond between these will break. Covalent bond will break. That's too much deep concept. I will not go into that, because whenever you will achieve breakdown, you will get large sharp current, and if you increase the V0, that means biasing voltage, width of the depletion region will increase and EFSA will increase, and as a result electric field will increase, and as a result covalent bond will break. So this is a normal operation of the Zener diode. Zener diode, what is the application of the Zener diode? I will discuss thoroughly all the operation of the Zener diode. So first of all, Zener diode will act as regulator. Zener diode will act as regulator, and it will act as also fluctuating input. Output can be fluctuated by input supply, or output can be fluctuated by load resistance also. So before going to the application portion, I will show you how a Zener diode circuit will act normally. So let's start discussion of the action of the Zener diode circuit. So whenever firstly what I have told you, that Zener diode will act as reverse bias. So whenever you are drawing a Zener diode voltage, Whenever you are drawing a Zener diode voltage, this is P of the Zener diode, this is N of the Zener diode, and if the positive end of the battery is connected to the P and negative end of the battery is connected to the N, then these will act as normal battery of 0.7 volt. If it is silicon, normal battery of 0.7 volt in forward bias. So in forward bias, Zener diode will act as what? In forward bias, Zener diode will act as normal diode, a normal battery. So whenever you are giving the reverse bias voltage, firstly recap that graph. Up to the breakdown voltage, the graph will act as broken wire. And in general, what we know, in the reverse bias, Zener diode will act as broken wire. After that, a sharp current will increase. After the breakdown voltage will be crossed. So whenever you are giving Zener diode reverse bias, reverse bias means what? Reverse bias means P side of the diode is giving negative, N side of the diode is giving positive end of the battery. So in the reverse bias, voltage of the diode is less than breakdown voltage. That means, I am showing by figure also. In case of I versus B, what we have seen, before crossing the breakdown voltage is I, this is V. Before crossing the breakdown voltage, Zener diode will act as, in this portion, means before crossing it, broken wire. So when you are giving Zener diode, reverse bias, so it will act as, that means it is N side and it is P side. So inside you are giving plus and P side you are giving minus. It will act as broken wire. Broken wire for what region? Broken wire for, here it is a broken wire, VB, that means voltage of the bias voltage of the Zener diode less than VBR, or you can say VZ. That means Zener voltage, bias voltage of the Zener diode, breakdown voltage, it is lesser than breakdown voltage or Zener voltage. Then it will act as broken wire. But when you are giving the input, let us consider input voltage is Vs. Let us consider input voltage is Vs. When you are giving that portion Vs greater than equals breakdown voltage, then the current is going to be achieved. A sharp current is going to be achieved because it is crossing the breakdown voltage. After it crossing the breakdown voltage, you will see these things. Vs, you are getting input voltage and output also corresponding to that input, because Zener diode actually works on which bias? Reverse bias. But up to which reverse bias? Less than breakdown voltage. But when it is crossing the breakdown voltage or Zener voltage, then a sharp current you can see in that case of Zener diode. So what we can get from this discussion? So we can get that number one, Zener diode will act in reverse bias. Number two, up to VZ or breakdown voltage, that means up to breakdown voltage, it will act as reverse bias. And after it is crossing the breakdown voltage, whenever it will cross the breakdown voltage, that means input voltage greater than equals breakdown voltage, a sharp current means what? That means after crossing the breakdown voltage, we will get a sharp current flow here. So that's the main operation of the Zener diode. So you can see from the circuit also, we can see from the circuit such as whenever here it is a circuit, here break Zener diode, here it is Zener diode, and here RL means what? RL means here load resistance. So here breakdown voltage, let's say 10 volt. Okay, this is breakdown voltage or Zener voltage, whatever. Vz is 10 volt plus minus. So whenever you can see that positive portion, I can show you by the different color also. Positive portion of the input voltage is connected to the negative side, here inside of the Zener diode, and here it is P side of the Zener diode. Negative portion of the Zener diode, negative portion of the input voltage is connected, positive portion of the input is connected to the negative portion of the Zener diode, and negative portion of the input is connected to the positive portion of the Zener diode. That means what? That means reverse bias, and reverse bias Zener diode will work. But up to which portion? Up to which limit? Reverse bias is also limit, na, biasing limit. So up to which limit? The limit is up to Vz or up to V breakdown. What is given as 10 volt. So whenever it will cross or equal, whenever input voltage will cross or equal to breakdown voltage, then what we can see, that portion of the Zener diode will act as this 10 volt battery. Whenever reverse bias is there, then it will act as 0.7 volt battery. But when after crossing the breakdown voltage, that means whenever V is greater than equals VBR or VZ, then such thing we can see. Here it is RL, and here V is greater than VR. That means it has crossed the breakdown voltage. That means this thing will act as 10 volt battery. Yes, that is the thing. This thing will act as 10 volt battery. So most important thing we are going to discuss now. What is that most important thing? That is power calculation. Power calculation in breakdown voltage. Power calculation in Zener diode. Extremely sorry for the inconvenience. Power calculation in Zener diode. So there are certain formula for calculating power of the Zener diode. So we will discuss that formula here. So whenever, firstly, for discussing that power calculation, I have to draw something. What we have to draw? What I have to draw? That I versus V voltage again. Now up to this Zener voltage, here I minimum, here Vz or VBR. Okay, now the formula at here corresponding to the Vz or breakdown voltage, here what we will get? We will get Iz or Iz minimum. That is what? That is knee current or Zener current. So we will write down the formula. Whenever Pz minimum is to be calculated, then you have to write Pz minimum equals Vz into I minimum. That means Iz minimum. So as I minimum, almost Pz equals Vz Iz. Main formula is what? Pz equals Vz Iz. Now you can regulate this Vz up to the limit, up to a certain limit. So what you can regulate? You can regulate also Iz also, but you can see from the graph also that Iz is very small. Iz is nearly, or I minimum is nearly 0. So whenever I minimum is nearly 0, that means Pz is nearly 0 also. Similarly, whenever you are going to calculate maximum power, Pz max, you have to write Vz Iz max. So for this supply is responsible for this Iz max, Pz equals Vz Iz max. Supply voltage or supply current is responsible, not load resistance. So this is the formula. So you will get much better whenever I will discuss a problem on this. So let's discuss a problem on the Zener diode. So first of all, I will discuss a Zener diode problem. A Zener diode is given. The circuit is shown in the such a way. Here, the Zener diode is given, and here current is given. Sorry, here 9-volt battery. Let me draw properly. Here 9-volt battery. Here resistance. Here Zener diode. Zener diode is about 6 volt. Okay, here 6 volt Zener diode, and here load resistance RL, and here plus, here minus, a positive battery, negative battery. So 9 volt. From this it is a given circuit. Here 50 ohm resistance. So in this question it is given that a Zener diode is given. Knee current, the circuit is shown, and it has a knee current Iz equals 5 milliampere knee current or Zener current, and maximum and minimum power allowed, maximum allowed power dissipation is here in this circuit. Maximum power allowed dissipation is Pz max equals 300 milliwatt. 300 milliwatt. Now in the question it is given, what are the minimum and maximum load current that can be drawn safely from the circuit? Iz minimum, load IL max, minimum load current, and maximum load current, IL minimum and IL maximum, that can be drawn safely from the circuit, keeping output voltage V0 at constant 6 volt. That means what should be the maximum load current and minimum load current to keep this Pz max? This is allowed power dissipation 300 milliwatt, and what will be the value of this IL max and IL minimum that can be drawn safely from the circuit, keeping output voltage V0 constant at 6 volt. That means we can keep the output voltage 6 volt constant. So let's start discussion. That means what? We can keep output voltage constant means what? So let's start drawing again the circuit. Here the battery, 9-volt battery, output is V0. Here 50 ohm resistance. Here the Zener diode is there. Here the load current is there. Here plus, here minus. Now Iz minimum or I knee equals what? 5 milliampere. 5 milliampere is given. And maximum allowable power is what? Pz max equals 300 milliampere, and Vz, that means Zener voltage is 6 volt. Now Pz equals what we know, Vz into Iz max. What we have now, we have Vz 6 volt and Pz max. Pz max equals Vz into Iz max. So what we have Pz max and Iz max. We have Pz max and Vz. So what we can obtain here? We can obtain Iz max equals 300 by 6. That means 300 milliamp. That was what was the power unit? Power unit was 300 milliwatt, and voltage is 6 volt. That means 300 milliwatt by 6 volt. That will be given by 50 milliampere. 50 milliampere is Iz max. Now coming to the circuit portion, some portion of the circuit. Whenever I am drawing some portion of the circuit, that is here it is the Zener. Now here it is the work of KCL. You can see it is the input current is coming from here. Here 50 ohm resistance is there already. Here 9 volt battery is there already. Here Zener diode is there already, 6 volt, and here load current is there already, RL. Okay, so whenever input current is coming, Is is coming. So here you can see it is distributed. I is distributed in Iz and IL. This Is input current is distributed Iz and IL. So we can write here Is equals Iz plus IL. Few moments ago, we have got Iz max, that is 50 milliampere. So here we can write IL equals Is minus Iz. But here, what we can tell? We can tell that we have to know the Is also. We have Iz known thing, Iz max known thing. But we have to know the Is also, na? Input current. For that, we will apply KVL, okay, here in the circuit. So firstly, clear this thing. Firstly, again I am drawing the circuit to make you understand the KVL things. So it is the Zener diode. It is the RL. It is the plus. It is a minus. It is 6 volt, 9 volt. It is 50 ohm. Okay. So whenever I am applying the KCL here and KVL also. So minus, what we can write from this circuit? Can write this is Is current. It is distributed here Iz. We will apply the loop equation here, and it is IL. So we can write here minus 9. It is plus here minus 9 plus Is. Here it is coming from Is. And 50 ohm resistance through it is coming. Is into 50 plus. Here it is coming through whenever. What I have told? We have told that whenever input Vs is greater than equals VBR, what we will get? It will act as 6 volt battery. It will act as 6 volt battery. This thing will act as 6 volt battery. So from the KVL we get minus 9 plus Is into 50 plus 6 volt battery, because I have discussed that 9 volt is greater than 6 volt. You all know these things. 9 volt is greater than 6 volt. You all know these things, because 9 volt is what? Input voltage Vs, and 6 volt is what? Zener diode voltage VBR. That means that Zener diode will act as what? Will act as 10 volt battery. That Zener diode will act as 10 volt battery. So from this equation we can write Is equals 3 by 50, that is 60 milliampere. Now IL equals Is minus Iz. But what we know? We know Iz max. We know the Iz max also. So whenever we are putting Iz equals Iz max. So Iz max, what we have got? Firstly we have got 50 milliampere. So whenever when we will subtract Iz max from input current Is, it's very easy that we will get IL minimum. IL minimum equals what? Is minus Iz max. Because input current is what? Input current is Is. And maximum knee current is what? Iz max. So whenever we will subtract Iz max, means maximum knee current, from the input current, we will get what? We will get IL minimum load current, 60 minus 50, that is 10 milliampere. One answer we have got, 10 milliamp minimum load current we have got. Again we have to get maximum load current. To get maximum load current, what we have to do? IL max Is minus, now what it should be? It should be Iz minimum. Iz minimum we have first already obtained, that is 5 milliampere. That means 60 minus 5, that is 55 milliampere. So this is IL max. So that is it for today. For the time being, thank you.